Chemistry. I'm here recording with Martin, and these are the review questions for Module 8. Review questions can be found on page 283. Thanks, Martin. Martin, will you please read number 1?
What are valence electrons and why are they so important in chemistry? The answer can be found on page 248, where it has definition of valence electrons, which is the electrons that exist farthest from an atom's nucleus. They are generally the electrons with the highest energy level.
Correct. Okay, so why are they so important in chemistry? Well, in fact, the whole periodic table is organized based on valence electrons, right? So if you look at each column of elements has the same number of valence electrons, okay? Electrons in their outermost region. And that means, in fact, that they actually have very similar chemistry. And so that's why valence electrons are so important in chemistry, because the same number of valence electrons gives them similar chemistry. Okay? Did you write that down, love?
I have.
Good. Please read number 2.
How many valence electrons are in the following electron configuration? 1s2.
Wait a minute. I'll write this down. 1s2. Thank you.
2s2. 2p6. 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p3.
So the definition of valence electrons was it was the electrons in the outermost, the electrons that exist farthest from the atom's nucleus, right?
Yeah.
Okay. So how many energy levels do we have here?
3.
Let's look. 1 is 1 energy level, right?
Yeah.
That's 1.
5.
Then we have the 2s and the 2p. That's 2. Okay. Then we have a 3rd energy level. And we have a 4th energy level. And then this 5th energy level, right?
Yeah.
Would you agree with that?
Yes.
Actually, this is in the 3rd energy level. That's why it has a 3. So we're only looking at the 5th energy level.
So that's 5 valence electrons.
Yeah, this is actually part of the 3rd, part of the 4th. So we have 5 valence electrons, the highest energy level, the 5th energy level.
The chemistry of life is based on carbon. This means that all of the molecules which govern life-giving chemistry have carbon atoms as their principal component. Chemists have often speculated that there could be a life form with a chemistry based on silicon. Why?
Let's look at the periodic table to see the answer to that. So if you look at the periodic table, Martin, where do you find carbon?
Carbon is in the nonmetals. It's number 6.
It's number 6, and it's in what column?
4A.
4A. Okay. So what are some of the other elements in that column? What's right below it?
There's silicon.
Silicon. What else?
There's GE, SN, and PV. Don't know what.
So what's GE? Look up in the other.
GE. That's germanium. SN is. Oh, there it is. It's tin. And PB is.
It's lead, actually.
Okay.
Isn't it? Plum bum?
Is it?
Yeah, it's plum bum in Latin, which is a great name.
Plum
Bum bum.
That is the best element on the whole table.
I think so. All right, so since we were saying that in chemistry, the valence electrons in the columns are the same, so they have similar chemistry, the theory is that life could be based on maybe some of these elements. Now, the interesting thing is there's actually a organism that lives in plankton, which does have a silicon structure.
Cool.
I forget what they're called, but you can look them up. Okay, so that's the answer to number 3. That they're in the same column, they have similar chemistry, so we believe that there could be life forms with these other bases. Please try to shake the table last. Thank you. We're going to do number 4, and then we're going to pause and do another video. Please read number 4 when you're ready.
What are the noble gases, and why are they important in chemistry?
We talked briefly about them in the previous module, Module 7, where we were talking about how you can avoid having to write out this whole electron configuration, right? What you do is you go to the last column. What is the last column? Would you look at the periodic table? That will help you. What is the last column in the periodic table?
8A.
8A, okay? So look, this will be one of the 8A elements because it has complete energy levels. You understand that?
Yes.
Okay, wait a minute. So let's say we wanted to talk about this element, for example, K, which is potassium. We would go, it's number 19, we would go to number 18, argon. And so we would shorthand argon because that has a complete energy level. And then we would continue. Do you remember doing this in the last module?
Yeah.
Right. So these ones in column 8A are called the noble gases. And they don't have, what do they not have? They don't have any openings in their valence electrons.
Right.
They're not missing anything. All their energy levels are complete. And so these elements are very
dense, stable.
Stable. They're very stable. Okay? So the noble gases are the elements in group A, the far right of the periodic table. And they're important because they have very stable electron configurations because their highest level energy orbitals are all filled up. So they're not looking for any love. They're all happy. Okay, we're going to pause this and come back with another video for the review questions for Module 8.